Yeah, hi. So, so, Let me introduce myself. So, I am Shubhanu Halar. So, I am a PhD student at IIT Delhi. So, today I will be discussing about the course for design analysis and algorithm. So, I will be discussing some questions that will be basically the example based questions which will be very helpful for you to solve the quizzes and for the examinations. So, I have prepared some set of questions so that we can start from very basics. Then, after some time, we will be moving towards also the previous year's assignment questions also. So, let us discuss today's topic. So I think I am audible and my screen is also visible to you. So if there is a there is any problem, so then let me know. And also, as there are more number of participants are here, so please, so I will be showing you some questions, and I expect from you that you give me the answer of that question first, trying by yourselves. So the chat is the very best option for doing so. So I request everyone to give your answer in the chat box. Okay. Yeah. So, as you already learned about the asymptotic notations uh, from the uh, course instructor, that that if we plot uh, n is the number of input size, and t is the time, then we have a function which grows like this. So we have to basically uh, find an upper bound uh, for this function. So we have to find this c of gn, and give me a second. Yeah. So we need to find the upper bound of this function fn, which is by gn. So there is a question given that we have a function a, and there is a for loop. Okay, and I have written this program. This is not based on any programming language, but this is a general kind of approach basically. So please guys be on time. Okay, so it's already 6:04 now, and everyone is coming. I have to admit each and everyone. Okay, fine. So this is not a specific language, C or C++, not that like. So we have a general framework, and we will be trying to find out the time complexity of each part of the code. Okay, so first one is we have a for loop, and there is a print statement that where you have to print your name. Okay, so can you tell me that which answer will be the correct one? So please type in chat only. Okay. So you can see here that for I is equal to 0 and I less than n, it is printing. So maybe if I is equal to 0, it print your name. For I is equal to 1 also, it will be printing your name. I is equal to 2 also, it will be printing your name. So if you run for n times, so it will print your name for n times. So the correct answer is basically the option B. So I think most, yes, I think most of them, most of you have given the right answer to these questions. So we will be moving to question number 2. So this is our second questions. Okay. So I think you all are familiar with the big O notations. So as you know that there are three kind of notation. One is worst case time complexity. Okay, that is we denote by big O. Second is best case time complexity, that we denoted by big omega, and third is the average case time complexity, we denote it by theta. So best case means if we run it for only one time, only one iteration, I can close my statement. So this is the best case. Mostly we are committed to find the worst case time complexity. Okay. Yes, if you have Sanu, if you have any doubt, please write in chat. I'll try to give you the answer. Yes, yes. Please write in chat what you have doubt about the previous question. Yes, yes. It is. Yes, answer can be C in previous question. Like if we go back to the previous question, so Sanu is saying that C and D also can be a answer of the question. C and D. Okay. Yes, you are right, because this is our function fn. So you can draw as many function above this fn. Okay, but we 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 wanted to find the big O, the worst case complexity. Okay, so we will be taking the lower bound in this case. Okay, so if this is the order of n, then it will be order of n square, and this will be order of n cube. But you see that only for n times your name is printing. Okay, so that's why this for loop is running for n times from 0 to n, but it is not running for n square time, it is running only for n times. Like take a simple example, like we have 100 students in our class, so you have given your pen to any of the 100 student. Okay, now you have to, you don't know that to whom you have given the pen, so you have to find out the person. So how you will find out from the 100 students? So if you ask the first person that do you have my pen, then ask the first person to ask another 99% about the same. Okay, so that is the order of n square time complexity, like each one is asking everyone. Okay, and if you go individually to each and everyone, like if you go to first person, then if you go to second person, this is called the order of n. Like if you are going to each one and asking for the same. Okay, and what else you can do, how you can reduce the time complexity, how you can reduce your work? So you can divide the class by 50-50. Okay, so 50% in left side and 50% in right side. Then ask one from left side and ask one from right side, and then ask that do you have the pen. So whenever you find a pen from left side or right side, you stop it. So this is the order of login. Okay. So I think I have cleared your doubt. So this is the second question that yeah. So only Misty Gopher has given the answer, I think, for problem number 2. So this is the problem number 2. Yeah. So how can we solve this kind of problem? That you can see that here this uh, I this I is a variable and s is also a variable here. So increment of I is linear here, like I grows like 1 2 3 4. Okay, like you can only do I is equal to I plus 1, you can't do I is equal to I square. And increment of s is dependent of I. Okay, so now how can we verify this one? So I is also starting from 1 and s is also starting from 1. Okay, so and what is the stop condition? Whenever s less than is equal to n, we will stop. So this is called stopping criteria. Okay, so how can we start? So first we take I. First our code will execute from here, then we will be coming to this step. So we will check that s less than is equal to n or not. So in first step, in the first step, s is equal to 1 and I is equal to also 1. So and n is maybe n is a very big number. Okay, maybe 1000 or 10,000. Okay, so first we check that s is less than 1000 or 1000 or 10,000 or not. So our if our condition is 2, then we will be coming to this step, I is equal to I plus 1. So I will be 2 now. Then what will be s? S will be 2 plus 1 3. Okay, this 2 plus 1. So this is s is equal to s plus I. So this was your previous s and this is your now I. So this, that's why you will get 3. Okay, in when I is equal to 3, then s is equal to also 3, then you will check 3 is less than is equal to n or not. You will be coming to this I is equal to I plus plus, that means I will be 3. Then what you will do, s is equal to s plus I. Now what was the value of s? That was 3, and what is the value of I? That is 3 now. So it will become 6. Okay, for 4 it will become 4 plus 6, that is 10. For 5 it will become 10 plus 5, that is 15. Okay, so maybe this I is going up to k. Then up to which number it will grow? So maybe this grows up to n number, like whenever n is less than is equal to n only, then only it will stop. Like when s will greater than n, then only it will stop. So now s value has reached n, but what is this n? So you can see that n is nothing but sum of first k natural numbers. Okay, so k into k plus 1 by 2. Yeah. So k is equal to k plus 1 by 2. So this is the value of n when our program will stop. So now k is equal to k plus 1 by 2 greater than n. Then we can write it like k square plus k by 2 greater than n. Okay, so what will be the value of k? So you have to take the maximum one. You can see that k square is equal to n, so you can write like k square greater than n. So k is equal to big O of root n. So from here you can write like that k greater than root n. Okay, so like this. So the correct answer is option D. Now come to the third question. So please first try yourself what will be the answer. So some of you are giving correct answer and some of you are not giving the correct answer. So please try like the how you will start thinking. So you can see here that I is starting from 1 and ending at n. J is starting from 1, but j is dependent on the I. So here is a catch, j is dependent on I, and always k is starting from 1 and k is ending at 100. So what you will do in this case? So take the value of I is equal to 1 and see what happens in terms of j and k. So if you take I is equal to 1, then you are starting from here for I is equal to 1, then you will be reaching here for j is equal to 1, and only here only you will stop because j will meet the stopping criteria, which is 1 less than is equal to 1. Okay, then so you will be meeting this condition and you will come to this loop, k is equal to 1 to 100. So j is equal to 1, and then you will be running this portion of the code. So for this portion of the code, so your k will run for 100 times. Okay, so you can then try for I is equal to 2, what will happen? So for I is equal to 2, j will run for 2 times, then k will run for 2 into 100 times. Then for I is equal to 3, j will run for 3 times and k will run for 3 into 100 times. I think now you are getting some sense, like if this goes up to n times, if I is equal to n and j is equal to also n, then it will run up to n into 100 times. Okay, so how many times it will run? So you can see here that first it will run 100 times for I is equal to 1, then it will run 2 into 100 times for I is equal to 2, then it will run 3 into 100 times. Like this, it will run up to n into 100 times. Okay. So if you take this 100 common, so 1 plus 2 plus 3 plus like this up to n time. So this is a very well known thing to you. So n into n plus 1 by 2. So this is the case. So now you can see that you will be getting n square plus n. So what is the big term in the whole formulation? That is n square. So our answer will be order of n square. So C is the correct answer. Fine. Okay. Now we will move on to the next question. Question number 4, I think. So please try to solve this question in the way I showed you just now. Okay, like start from k is equal to 1. Check the condition of I is going from 1 to n. Check the condition of j is now going to I square. Whenever j is less than or equal to I square, up to that j will learn. Okay, so in the previous question we saw that j was running up to j less than or equal to I, but here there is a change, that whenever j less than or equal to I square, up to I square it will run. Also here k is dependent on n. Last time k was a constant, like k was always running from 1 to 100, but now k is running up to n by 2. So please keep in mind and try in the same manner. Okay. Yeah, Alak Singh Sethi has given answer. Sanu is also giving the answer. Okay, from your group, some people are giving the answer C and some people are also giving the answer D. So I will request everyone to try in the same way I have already showed you. Okay, like so if this is a question, so try from I is equal to 1. Okay, so what will be the case when I is equal to 1? When I is equal to 1, j will learn till I square. So 1 square means 1. So j will learn till 1. Okay, and how much k will run? K will run till n by 2 into 1. Okay, because why I am running this, I am writing this 1, because k will run like j times. So this is basically the value of j. So as now we have j is equal to 1, so we are writing this as 1. Okay. Now for I is equal to 2, what will be the value of j? Value of j will be 4. And how much time k will run? K will run till n by 2 into 4. Okay. So you can see that for I is equal to 3 also, j is equal to 9, and k will run up to n by 2 into 9 times. So like this, when I is equal to n, j will run till n square, and k will run till n by 2 into n square. So that is basically k is equal to n cube by 2. So I got k value as n cube by 2, but some people are giving answer that is n to the power 4. But why that is n to the power 4? Because it will run from I is equal to 1 to n, so n times. So I have to also add this, like n by 2 plus n by 2 into 4 plus n by 2 into 9 plus n cube by 2. So if you take n by 2 common, you can see that I am running till 1 plus 4 plus 9 plus up to n square. Okay. So this is this is also then well known formula, that sum of square numbers, that is n into n plus 1 into 2n plus 1 by 6. So now you can see that how many n's are there? 1, 2, 3, 4. That's why our answer will be n to the power 4. I think these questions are clear to you. So if anyone has a problem, then please raise your question in the chat box. Guys, please try to come on time. Okay, now this is 6:28 p.m. So this is our next question, that is question number 5. So please try by yourself first, then I will tell you the answer also. Like you can see that here we have some integers like I, j, k and n. So I is starting from 1, and it will check the condition I less than n or not, and every time it is increasing by multiplying 2. Okay. So if I start from 1, then so I will be starting from 1, then I will be checking that I is less than n or not. So n is a very big number, so n is a like 10,000 or very big number, so it will check that I is less than n or not. So okay, it is true, then I will be 1 into 2, then I will be this value into 2, so I will be basically 1 2 4 8 16 like this. So this is basically 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 16, up to which will reach. So it will run up to n, because whenever I greater than is equal to n, so our code will stop. You can see this. Whenever I less than is equal to n, our code will stop. So that's why it will run up to n. So how can we write this one? So we can write like this will be 2 to the power k. So what is the value of 2 to the power k? So right, like 2 to the power k is equal to n, then k is equal to, so you apply log both sides, log base 2 basically. So like this. So if this is the first time, so I am showing you like log base 2 to the power k and log base 2 n. Okay, applying so now this is by applying log. So the answer will, this k will come here, and log 2 base 2 will become 1, and it will remain the same, log n. So this log n is our answer. So C is the correct answer. So I think for this question everyone has given the correct answer. So this is the next question. Let's see who give the answer first. So your task is to check from where I is starting and where I is ending, where J is starting, J is ending, and also the increment here. Okay, so here you have to focus. Square log, yeah. Shakshar Das has given answer C. Okay. Let's see how we can solve this one. Yeah, Misty has also given the answer. Okay, okay. So this is a simple one. Basically, you can see here there's that I is starting from n by 2 and it is running up to n. That means that this is running for n by 2 times, and J is running from 1 and J is running up to n by 2. So it is running for n by 2 times, and also you can see here that K is growing multiply of 2 or the power of 2. So from the last example also you can see that it is log n base 2. Okay, so combining this you can see that n by 2 into n by 2 into log n base 2, that is n square log n. So this will be the correct answer. So I think for this question everyone has given the correct answer. Yeah, very good. can see clearly this will run for n by 2 times. Also from the last example we know that this will run for log n times. So this is a tricky one, find out. Yeah, I think 5 of them is given some answers. Let us check that. Yeah, so this will also run for log n time. So right, correct answer is basically log n into log n, that is n into log n square. Okay, so this is basically the correct answer. So the question is n is greater than is equal to 2. Okay, so n start from 2, 3, 4, 5 like this. Okay, so a is our function. Now you have to find out the time complexity for it, that when it will stop and all.
Excuse me, sir.
Yes. Yes.
Sir, I had got a little amount of doubt regarding the previous question.
Yeah.
Sir, that question was actually running up to n by 2, and sir, it was incrementing by 2. Then, sir, the total number of times the second loop is running is a log n divided by 2, right, sir?
Oh, can you please write in chat instead of like saying?
Okay, sir.
Okay. Show us the calculation of the number of times the multiple loops is running in distance. Yeah. So the question was that uh, calculation of number of times the middle loop is running. So this is middle loop is running from 1 to n by 2, and it is growing up to power of 2. Okay, so uh, so j is starting from 1. Okay, and then if j is starting from 1, then j will be growing power of 2. So there will be 2, 4, 8, 16, like this. Okay, so j will stop till n by 2. So j will stop when j will be n by 2. Okay, so you can see here that this is 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4. Okay, this will be 2 to the power k. Okay, so as I also have shown you in the previous question, like here only, like, so you have to, so these two are equal. Okay, yeah, this one. So 2 to the power k is equal to n by 2. So this is basically 2 to the power k plus 1 is equal to n. So if you apply log on both sides, so you can also write like this, that 2 into 2 to the power k is equal to n. Okay, so if you apply log, that will be log of 2 into 2 to the power k, is equal to log n. Okay, so you apply log base 2, that will be log 2 to base 2 plus log 2 to the power k is equal to log n. So it will be 1 plus 1 plus this k will come here, k into 1 is equal to log n. Okay, so k will basically will equivalent to log n. Sorry. So k will basically equivalent to log n. I think Shak sir, is your doubt?
Yes, sir. Thank you, sir. I am able to understand. Thank you, sir.
Yeah, welcome. So we were in this question. Yeah. So we were in this question that n was while n greater than 1, so for 2 it is greater than 1, and 3 it is also greater than 1. So like this, from 2 basically, maybe, or maybe from 1000, from a greater than 1 number it will start. So maybe n is starting from 1000, or maybe starting from something else. So, and each time n is decreasing by 2, like you are doing n is equal to n by 2, so the value of n is decreasing. So what will be the time complexity in this case? So like if you, so here like you can think in this way, like if you start from, so for n value, if you start from 2 to the power 1, then what will happen, that you will check the condition that while n is equal to 1 or not. Okay, so it will check that, okay, it is fine, that n is 2 is greater than 1, so our condition is 2, and it will come to this point, n is equal to n by 2, so it will become 1. Fine. Then if you start from 2 to the power 2, then again it will start from, check this condition, n is greater than 1 or not. So this 2 to the power 2, that is 4, is greater than 1. Then what it will do, that n will be divided by 2, so n will be 2. Okay. Then again from this line it will go into while loop. Again it will check that n is greater than 1 or not. So it will find that okay, n is greater than 1, and when n will greater than 1, whenever it will come to this point and it will check that n is greater than 1 or not, it will find that okay, no, 1 is equal to 1, n is equal to 1, so then it will stop. Okay. So if you start from 2 to the power 3 also, then it will check, then 2 to the power 2 will come, then it will check, 2 will come, then it will check again, then 1 will come, then it will stop. Fine. So this will be the procedure. Okay. So we can see that n is equal to basically 2 to the power k. If n is equal to 2 to the power k, then it will stop. Okay. So we can as we have already seen that k is equal to, we can write applying log both sides, we can say that k is equal to log n times. Okay. So the answer will basically be the log n. Yeah. So most of you have given the correct answer. So this is the next question. So this was question number 8. So this will be question number 9. Yeah. So now you also be wondering that how you will be start from this case. So here like previously we were seeing that there were 2 or 3 nested for loops, but here you can see that there are for loop also a while loop. So how you will handle this case? So in this case, I am giving you the someone is giving some answer. Sheet Sagar has given I think n log n. Okay, we'll see. Don't do. So I am giving you a hint that from where you will start basically. So start from k is equal to 1, because you see that here that n is basically 2 to the power k. Okay, and you know that this loop will run for n times, and you don't know that how much time this loop will run. So start from k. So start from k value. Okay. So if k is 1, then what will be the value of n? Then n will be 2 to the power 1. That is basically, yeah, that is 4. Okay. And what will be the value of j? So each time value of j will start from j is equal to 2, and j will run from j square. Okay. So j will run for 2. It will start from j is equal to 2, and it will come to this condition, j less than n or not. It will satisfy this condition, and j will be j square. That will be j will be 4. Okay, and then it will stop executing. then k will start from 2, then n is equal to 16, then j is equal to 2 4, and it will come again and it will be 16. Okay, so this is how. So here you can see that n is running for 2 times, here n is running for 3 times, so like this. Okay, so as n is equal to 2 to the power k, then if you apply log n, it will be 2 to the power k log 2 base 2. Okay, we are applying log base 2. Okay, so log n is equal to 2 to the power k into 1 basically. Okay, so we have to apply, we have to find the order of n, not order of k. Okay, so we can see that we have to, if we have to find the we have to find the value of k in terms of n. So we have to, like, then we can, as there is 2 to the power k, then we will apply log again, so log n, so then it will be log 2 to the power k, it will come log n is equal to k. Okay, so what will be the value of k? Value of k will be order of log n. Okay, so I think for this question no one has given the correct answer. So if you have any doubt, please type in chat. Okay, if you have any doubt about the question, how we have solved this one.
सर ये n इज इक्वल्स टू 2 की पावर भी k था,
Yes.
तो आपने ये log स्क्वायर n इज इक्वल्स टू 2 की पावर k, ये फर्स्ट स्टेप कैसे करा इसका?
This one.
यस सर.
Like this one, I think you are talking about.
Yes.
Yeah. So I am applying log both side only. Okay, so I had this one, n is equal to 2 to the power k. Okay, so if I apply log, it will become log n base 2, and it will become log base 2 to the power k. Okay, so this will, so this 2 to the power k will come here. Okay, log 2. Okay, so this is same. Okay, so you have 2 to the power k, and this log 2 base 2 will become 1. Okay, so you will have log n base 2 is equal to 2 to the power k. Is it clear to you now?
Yes sir. Yes.
Oh, thanks.
Yeah. So this is the next question. Do you know what type of algorithm is this? Like this is a type of algorithm. So we have two types of algorithm basically.
So this is a recursive algorithm.
Yeah.
Tail recursion.
Yeah. So for one we have iterative, and one we have recursive algorithm. So for we can find time complexity of this iterative algorithm or recursive algorithm. Okay, so time complexity is not the thing that you will be able to finish your execution within that time only. Okay, like the amount of time required to execute your program is basically proportional to the time complexity. Okay, so also if you have any doubt about this time complexity, like why really we are doing this so much of maths and all, and this thing, So if you type any if you search in internet that time, there is a time function in the compiler also, so you can find out that if you play with this the time function, you can find out that is that is really uh, is that is really a practical application of this time complexity thing. Okay, so we have two types of algorithms, one is iterative and one is recursive. Okay, so other types of for other types of algorithm, that is only order of one, like that is only constant time algorithm. Okay, so for iterative algorithm only, like when a program like this and you have some for loop, okay, and you have some statement to run and it is a end. Okay, and for recursion it will start from this, and it will in recursion your function will call the same function again. Okay, like your function name is a, in program also you are calling the same function, you are calling the same function multiple times. So this is called the recursive equation. So 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 we'll see that how we can solve this type of equation. Okay, so these are basically two types of algorithm. Yeah, sure. Please type your question in chat, or you can
Okay, sir.
yeah, or you can
Sir, I
unmute.
would love to speak, sir. Sir,
Please.
actually, in this type of question, sir, for example, the value of n is given in the question and the value is some negative number. For example, -5. Then, sir, the loop is going to run infinite number of times. Then, sir, in that case, what will be the time complexity, sir?
Like maybe in this program only we can find out, like so this program only, like if n is -100, okay, this is the starting point are you talking about. So if n is starting from 100, so you can see that n will not cross this border, so it will come to this point only when it will pass this if loop. I think your doubt is clear now. So basically first I need to show you some trick that uh, how we can solve this recursive equation. Okay, so maybe how we can start from what point. Okay, so there are two methods. First one is a back substitution method and one is tree method. Okay, so in back substitution method what we can do that, okay, so this is basically uh, for tn time the an will run. Okay, so for then we will be doing some constant amount of work, so that's why for this, if this is a constant amount of work, okay, so that's why I am writing 1. Then we will be doing tn minus 1, sorry tn minus 1, fine. Okay, I think you got my point. Like to solve this an we have to do tn amount of work. Okay, so what is this tn amount of work? So first we have to come here, we have to check this if loop. So this is the this is a constant amount of work. Then we have to come an minus 1. So this is a t, for this one I need tn minus 1 of time, fine. So this is basically the thing. Okay, so what can we do? So to do this tn minus 1 amount of work, we can do, we have to do the same also, same thing, like for n minus 1 when it will be like a n minus 1, so it will come to this loop, it will check the condition, then it will come here also. So I have to do tn minus 2. Okay, and for tn minus 2 I have to do n minus 3 amount of work. Okay, so now how can we solve this one? So from here we can see that t n is equal to 1 plus t n minus 1. So we know the value of t n minus 1. If we put this value here, 1 plus t n minus 2. Okay, then so this is 1 plus 1 plus t n minus 3. So that's how, like, from here we know the value of t n minus 2. Okay, so that's how we can solve the problem. Like, so here it will come t k plus t n minus k. Like, you can see that for 3 it was 3 plus t n minus 3. So that's why I have written for k times it will run till k if loop it will check. That's why k plus t n minus k. Fine. So when this problem will stop, like the main question is like when this problem will stop. So this will stop when this n value is basically 1. So that means this will stop when if n greater than 1. That means if n value is 1, it will stop. Okay, so n minus k is equal to, if n minus k is equal to 1, then it will stop. So what will be the value of k? Value of k is equal to n minus 1. Fine. So now if we put this value of k here, if we put this value of k here, so it will come n minus 1 plus t n minus 1. Okay, so n minus 1 plus t of, it will become n plus 1 because minus n plus 1. Okay, it will become 1. So so 41, how much amount of work we have to do? We have to do 1 amount of work. So our answer is n. Okay, so our answer will be order of n. So this is called the back substitution method. So how we started? We started from the tn. Okay, to do tn amount of tn computation. First we have to check this if loop. To check this if loop, we need a constant amount of work, that is 1, and then we have to do tn minus 1 work. Okay, so we know for tn minus 1 we also have to do this constant amount of work. Okay, that is 1, and then we have to do tn minus 2 amount of work. For tn minus 2 we have to do 1 amount of work, then n minus 3 amount of work. Okay, so that's how, if we substitute these values in here, so and one thing is that when we will stop at kth step, this is very important, that at kth step we will be working till t n minus k. Okay, so if we substitute the value of k here, we will be getting t of 1 and like this. Okay, so this is the back substitution method, and the problem with this method is that it is very slow. So that's why we came up with another method also. Yeah. So now my question is that I have written some function here. So you have to give me the answer in chat that which function is greater than which function. Like for each case, like for A, for B, and for C, which one is greater? No. Shiv Sagar, listen. Like for between A, like which one is greater? Like 2 to the power n is greater or 2 to the power n square is greater? So this one, like this, I want the answer. Okay. So I want 2 to the power n greater or n square greater. So what will be the value here? Okay, for a for this one, so each one is saying that 2 to the power n is bigger. Okay, so how you can find out that thing? So you can see that you have to came up in terms of n, but you have power of power 2 to the power n. So what you will do in this case? So simply apply log. Okay, so if you apply log, so log to the power n base 2. So also here in n square also you apply log. Okay, log to n square. Okay, so this n will come here, this n will come here. Okay, n log 2 base 2. Okay, in this case 2 log n. Okay, so this log 2 will become 1, this will 1, and this will log n. So this is basically n and this is log n. Okay, between n and log n, if you put a very big value of n, you can see that n will be always greater. So for this case 2 to the power n will be greater than n square. Okay, then for n square and n log n, know the power of n is greater than n, the power of log n is greater than n square greater than n log n. Yes, Shaksar, you are right. N square log n. So you can see that n into n and n log n. Okay, for the second one, for b. Okay, so if you cut this one, then between n and log n always n square will be the big one. Okay, for n to the power n and n to the power log n. So here n to the power n will be better. Okay, so now you have some functions. Okay, so you have 4 functions. So you must encounter some type of question, this type of question. Okay, and also in exam you will be getting this type of question. So this type of question is very important, like which one is bigger, like so you have to give answer like f1 greater than f2 less than f3. So you have to find, you have to come out in this way, like which one is greater than which one. Okay, so how you will begin in this scenario? Okay, so if you have this type of functions, so you have to find that which one is the which one is bigger. Okay, so take a deep look into these functions. Okay, take a deep look first. Okay, so one is 2 to the power n, one is n to the power 3 by 2, one is n log n, and one is n to the power log n. Okay, so first take a deep look and then we will discuss. So I think you know about the exponential function and polynomial function. So you can see that this is a exponential function. Okay, this is a polynomial function. Okay, this one is also a polynomial function, and this is a exponential function. Exponential means basically n to the power something. Okay, so exponential are much bigger than polynomial. Okay, so we have so we know that from these two will always be the greater one. Okay, so between these two exponential function, so by looking into the value only, like what do you think that which one will be a greater one? So I I will I think that 2 to the power n will be a greater one. So I'll start from 2 to the power n to solve this problem. Okay. So what I will do if I was okay. Okay. So you have already given the answer, but did you really check all did you really compared all the thing, or just you wrote the answer? Please check, or like with each and every function, check each and every function, then write the answer. Okay. So in my opinion, like I'll start from the first one because this is the exponential function, and just by watching the function I assume that this will be the greater one. So I will be then comparing these two exponential function, to the power n and log n. So what I will get, so again I will apply log. Okay, I will get n log 2 base 2 and log n log n. Okay. So this will become 1, so it will come n, it will log n log n. So I can see that this is greater. Fine. Then what I will do, I will be coming to this. Then I am sure that 2 to the power n is greater now. Okay, between 2 to the power n and n to the power log n. Then I will check 2 to the power n and n to the power 3. Okay, so let us keep track of the thing. So first I am checking this one. Okay. Second I will be checking this. Okay. So second we are checking 2 to the power n and n to the power 3 by 2. So it will become log n 3 by 2 log. Okay. Oh, sorry, I have made a mistake. N log 2 base 2, that is n and 3 by 2 log n. So this is n 1.5 into like log n. So always n will be greater than log n. Okay. So 2 to the power n is greater. Fine. So then what we will do, that we will be checking, we have to check with n log n also, like n 3 by 2. So we know that this 2 to the power n is greater than everyone. Okay. So I will be, so my next target will be checking these two one, that n to the power log n and log n. Okay. If we check these two one, so if I apply log here, so I will be getting log of n log n and log n log n. Okay. So this is basically log n plus log n. Okay, and this is basically log n log n. Okay. So what you can do, that you can here in this situation where you have this type of thing. So I will be coming. Okay. So you can put a very big value here. Okay. So if you put 128 in terms of like you can put 128 in terms of n. Okay. So or maybe 1024. So why I am taking 1024 or 128? Basically these two are, yeah, basically these two are functions of 2. so that's why I'm taking. So if I take 2 to the power 10, 2 to the power 10 is basically 1024. Okay. So log 2 to the power 10. Okay, and here it will be log 2 to the power 10 and log 2 to the power 10. So here you will get 10 plus it will become 1 log 10 and 10 into 10. Okay. So you can see that this will be the greater one. Okay. So n to the power log n is greater. So f4 is greater than f3. Okay. Now what we need to check that n log n and n to the power 3 by 2. N log n. Now we have to check these two. Log n and n to the power 3 by 2. If we check these two, log n 3 by 2 log n, that is log n plus log n and 3 by 2 log n. Okay, so this will become, so this so also so this will cancel out. So log n greater than 3 by 2, one constant term, so this will be greater than 1. So the answer will become f1 greater than f4 greater than f3 greater than f1 equal f1. Yeah, Aporna Anil Kumar has given the correct answer here. F1.
Hello.
No, you have given the correct answer, so that's why. Yeah.
Hello, sir.
Yeah. Hello.
That F3 and F2, F2 is greater, right? So can you explain? Because only is n root n, n raised to 3 by 2 is n root n, right?
F3 and F2.
Yeah, F3 and F2.
Yeah. So okay.
F2 is n root n, right?
F2 is n to the power 3 by 2.
N into root n, square root of n.
This one.
N into square root of n will be n raised to 3 by 2, right?
Yes.
So one side I have n root n and other side I have n log n. So n cancel, root n is larger, right? So
yes. No, root n, between root n and log n.
Yeah, root n and log n, root n is large.
Root n and log n.
Root n is large. You can take any value like say 1000. Root n will come in 30 range.
Okay. I'll solve your problem. Like I got your problem. Like okay.
Yeah.
So this was our case. So this was our case that where we got stuck. But n to the power log n and n to the power 3 by 2. So also we can write like
Sir, now 10 power log n, n into log n, right? It is F3.
Sorry. Yeah, sorry. In log n. Okay. So we can write like 1 plus 1 by 2. Okay. So that is saying that this is n into root n. This is what you are saying.
Yes, sir.
Yeah. So n and n will be cancelled out, and we have log n and root n.
Yes.
Okay. প্রকাশ, লগ এন আর রুটেনের মধ্যে কোনটা পড়ো? কিছু না কিছু না, লগ এন আর রুটেনের মধ্যে কোনটা পড়ো? সেট করে সার্চ করে বলতো। লগ ইন অ্যান্ড আর রুটেন। So root n will be greater than log n. So n3 by 2 will be greater than n log n. So n3 by 2, f2 will be greater than f3. Okay, so I think here we will have a problem. So f1 greater than f4 greater than f2 greater than, so these will be the correct one. Fine.
On this.
Yes.
No, sir, clear.
Okay, fine. Then okay, so all the problem can't be solved using this back substitution and like this. So we have some theorem called Master's theorem. So in Master's theorem, so I have written in some different way from the textbook. So so this is the theorem says that basically that if you have Tn, okay, then if you have given your equation like a into t of n by b and and theta of n to the power k into log to the power p of n, but there you have some condition that a must be greater than 1, b greater than 1, k greater than is equal to 0, and p is a real number. Okay, so then you have to check three cases for case 1, case 2 and case 3. Okay, so for case 1, if a greater than b to the power k, for case 2 you check a is equal to b to the power k or not, if a less than b to the power k. Okay, then you have to check, so first you have to check this condition, if a between a and b to the power k. Okay, then if this condition has been checked, then for first case if a greater than b to the power k, then you can commit your statement that the time complexity will be t of n, which will be theta of n to the power log a base b. For second case, if a is equal to b to the power k, then we have to check again the value of p. P is greater than 1 or not, greater than minus 1 or not, p is equal to minus 1 or not, or p less than minus 1 or not. Then for these three individual cases we will be getting three time complexity. Okay, so you can write this theorem in your copy, or maybe you can take a screenshot of this. So based on this theorem we will be solving some of our next question. So remember this thing, this master theorem only valid when you have some recursive program. Okay, and if you already given some function like this, okay, then only you can say that this will be your time complexity. So based on this theorem, you can see some question here. So find out the time complexity of the recursive algorithm. Okay, so like why I have written in like this. So I already shown you that for a is equal to n, if there is some work, and then you have to again uh, you are again calling this function only. Okay, like this, a of n minus 1. Okay, so this was your recursive equation. Then we formulate that Tn is equal to 1 plus Tn minus 1. Okay, so for this case I have already formulated you this type of equation. Okay, Tn is equal to 3Tn by 2 plus n square. Okay, so you have to use the master theorem, and you have to find the time complexity of this 4. Okay, so you have to use this theorem and find out the thing. So you have to start from basically the matching the thing. Okay, so first we have first our problem is Tn is equal to 3T n by 2 plus n square. So so in our master theorem we saw that in master theorem it was written like Tn is equal to a into Tn by b, okay, plus theta of n to the power k log to the power p n. I think so. So we have to check that here what is a and what is b. So a is basically here 3, so this is a, okay, fine. Now what is b? B is basically 2, and what is k? K is also 2, and what is p? P is 0, because we don't have any p log term here, so that's why p is 0. Okay, so now check that the condition holds for each and every one or not. Like first condition was a must greater than is equal to 1. So sir, can you show the master slide again? Yeah. Okay, now you just compare the things. Okay, compare the value of a. So a is greater than equal to 3. Okay, then b is greater than 1. Okay, and k is greater than is equal to 0, and p is any real number. Okay, fine. So all conditions like we have satisfied all the condition. So now we have to check what we have to check. We have to check uh, the comparison between a and b to the power k. Okay, so a and b to the power k. So a is equal to 3, and what is b to the power k? B to the power k is 4. So a less than b to the power k. Fine. 3 less than 4, that's why a less than b to the power k. So we got this. Okay, so we'll go here. So a less than b to the power k. Fine. We came to this condition number 3. Okay, now we have to check what is the value of p. So we did not have any p here. P is 0, so we are falling into this condition. Okay, 3a. Fine. So according to 3a, So what we are getting, that Tn is equal to, what was this, Tn is equal to n to the power k log to the power Pn. Okay, theta of n to the power k log to the power Pn, n to the power k log to the power Pn. Okay, so theta will become, so what is value of k? Value of k is 0, and what is value of p? Value of p is 0. So we will be getting theta of n square. Fine. So here we will be getting theta of n square. Fine. So yeah. So I think this is clear that how we are doing. Okay. So now B, problem number B. Okay, sorry. So what we can do? Space. So our problem number B was Tn is equal to 4T n by 2 plus n square. Okay, this one, Tn is equal to 4T n by 2 n square. Okay, so we will be solving this problem using this only. So first we will be writing the value of a, b, k and p. Okay, so what will be the value of a, b, k and p? So a value is 4, b value is 2, k value is also 2, and p value is 0. Okay, so now what we have to check? We have to check between a and b to the power k, because you can see here always we check first a and b to the power k. So between a and b to the power k, so I think these two are equal. A and b to the power k are equal. So we fall into this condition, a is equal to b to the power k. Condition number 2. Now we will check the value of p. So what is the value of p? So value of p is basically 0. So if p is 0 means p greater than -1. Okay, so we came to condition number 2a. So according to so a is equal to b to the power k, so and p is equal to 0, that is greater than -1. So according to condition number 2a. Okay, so we came into this one, 2a. So what will be our time complexity? Tn is equal to theta of n to the power log a base b, and so Tn is equal to theta of n to the power log a base b log p plus 1 base n. Okay, so that is, so if you put the value, so n to the power log 4 base 2 and log n. Okay, that is equal to theta of log 4 base 2. It will become basically, if you write like this, like log base 2 square. Okay, log n. Okay, so it will become theta of n to the power n square log n. Fine, I think this is clear to everyone. Okay, now quickly come into the C part. C is basically 16t n to the power 4 by n. Okay, so it will be n square. So I'll show you that in which condition this is falling. So it is condition number 16t n by 4. 16t n by 4. Okay, so it will condition number 1, because a, so a was basically, so we had 16t, so 16t n by 4 plus n. So a is basically 16, b is basically 4, k is equal to 1 and p is equal to 0. So between a and b to the power k, a greater than b to the power k, because 16 greater than 4 to the power 1. Okay, so we come to condition number 1, and what will be the value? N to the power log a base b. So that's why answer is n to the power log a base b. Okay, and what was value of a? Value of a was 16. Okay, so theta of n to the power log a base b, n to the power, remember, log a base b. Okay, so what is our a? A is 16 and b is 4. Okay, that's why I have written log 16 base 4. Okay, if this is the case, so it will be n log 4 square base 4. So it will become n square. So these are n to the power. Okay, these are n to the power. So for the last question, for this one, so for this question, a is 0.5. so basically you can see that a less than 1, because 0.5 is half, so a is less than 1. So that's why this does not this doesn't falls under any condition. So for this one we can't find out any time complexity. Okay, so like this, basically this type of not understand what is p. Okay, p is basically this value, n to the power k log to the power pn. Okay, so like if you don't understand what is the value of p, maybe I can give you an example. Okay, so suppose Tn is equal to 2t n by 2 plus n log n. Okay, so then what will be your a? So a will be 2. Okay, and this 2 will be your b. Okay, fine. And what will be your k? K will be, so here this is basically 1, so this will be your k. And what will be your p? So log n means log 1 to the power n. Okay, so this is basically your p. So if this was 2t n by 2 plus n log square n. Okay, so then it will be p is equal to 2. I think it's fine. Now try to solve this question. Yeah, Sadupya Chaudhary, you also has yes, D is not applied because k should be greater than 0, but k in this question k is equal to 0. Yes, that is also true. Yeah, so please try to solve this question. Yeah, so what will be the value of if 2000, 13? So basically this is m and this is n. So you are starting from m is equal to 2000 and n is equal to 3. Okay, so how you will solve the question? And your answer is basically 1. Okay, so try to see that what they are actually doing, that what is the value of m, n, and how the count value is going. So here always they are doing answer is equal to answer into n. Okay, so answer is starting from 1. Okay, so m is equal to 2000, n is equal to 3, answer is equal to 1. Okay, so and count also is equal to 0. Count is equal to 0. Okay, so first I will come here while answer less than is equal to m. So I will check this between these two, answer and answer, like 1 less than is equal to 2000. So I will be do count is equal to count plus 1. I will increase the value of count, and answer is equal to answer into n. So answer was 1. 1 will be 1 into n, like 1 into 3. Fine. Okay, then again I will be going here while answer less than is equal to m. 3 less than is equal to 2000. Then what I will do, I will be do 1 is equal to 2, and then 3 into answer into n means 3 into 3. Okay, so here we did 1 into 3, here we did 3 into 3. So here we will be, then for 3 we will be doing, here we have 9, so 9 will come here, and for here it is answer into here we are doing answer into n, so 9 into 3. Okay, so this is the case. So when the loop will stop, so whenever answer is equal to this one, whenever answer is equal to 3 to the power count, okay, then this loop will stop. Okay, so the loop will execute till we reach a power of 3 that exceed 2000. Okay, so if power of 3 exceed 2000, then only will stop. Okay, no, count is not 6 here. I'll show you why. Okay, so this is the main problem. So the loop will execute till we reach a power of 3 that exceed 2000. Okay, so answer is equal to 3 to the power count. Okay, so what is our answer? Okay, answer less than is equal to m. So 3 to the power count must be less than is equal to 2000. Okay, so 3 to the power 6 is 729. Fine, and what will be the 3 to the power 7? 3 to the power 7 will be 2178. Okay, so it will run when the function count value will 7, then only function returns. Okay, because from 6 for the 6th iteration, yes, okay sir, yes, Shakshar, I can understand what you are saying. Okay, like when look at this point. Okay, so like here maybe your answer is 729. Okay, so 729, then your count is 6. Okay, fine. Then what you will check, that you will check that 729 is less than is equal to m or not, like 729 less than is equal to 2000 or not. So you will get a yes answer. So whenever you will cross this while loop, you will come here, so your count value will be 7. Fine. So then what it will do, it will increase the value of 729 to 2178. Fine. Okay, now you again will go here and check 2178 greater than 2000 or not. 2178 greater than 2000 or not. Okay, so you will stop here, you will not come here. But what is your count value now? Your count value is 7, not 6. I think the answer is clear. Yeah. So this is the next question.
Sir, can you show the solution once?
Yeah, sure. Do you want to look at this one, or do you want to look at this one? or should I explain you again?
Sir, please keep it in the middle, sir, so that we can see the question and answer both. Thank you, sir.
Yeah. So this is the next question. Yeah. Suppose someone design a new airline routing algorithm called Magic Path. I think professor in the first class was talking about this magic path, and claims that its worst case time complexity is order of n square log n. Okay, which of the following statement is inconsistent with this claim? Okay, so Karthik is saying that D answer is correct. How? For every sufficient large n, there is an input of size n for which magic path requires time proportional to n cube. Yeah. So this is a tricky question. Like for this, you have to really understand about the big O or big omega or theta. Basically, what will be the upper bound? Like what will be the upper bound of any algorithm and all. Okay, so read the question again. That worst case time complexity is n square log n. Okay, so now first option is saying that for every input size of n, magic path is able to solve the problem in time proportional to n square. Okay, but not, because our time complexity is n square log n, so n square is less than n square log n. Okay, so I can't solve this within n square time for every n. Okay, so that's why this option is incorrect. Fine. Now come to option B. For some n, for every input size n, magic path is able to solve the problem in time proportional to n square. Like for some n, for every input size n. Okay, if there is a input size n, okay, so n can be any number. So whenever we solve a algorithm, we find the time complexity of a algorithm. So always we find the worst case complexity. Okay, so n, we can't change n because n is always a very big number. Okay, so we can really commit that for some n, for every input size n, we can solve the problem within n square time. So this is also incorrect. So this is inconsistent with this statement. Now for C, for every sufficient large n, there is an input size. Okay, if you are confused about this question, okay, this is basically you have one algorithm an. Now it takes order of n square log n time to execute. Okay, if this takes order of n square log n time to execute, now they are saying that for every n, can you complete this algorithm within n square time? No, obviously, because you need n square into log n time. How can you execute the algorithm within order of n square time? Like for every n, whenever n is equal to 100, whenever n is equal to 200, or for every n 1 to infinity, for every n you can't you can't finish your algorithm within n square time. So that's why this first option is inconsistent. For the second option, so they are saying that for some n, so they are saying that for some n, here that is every n. Okay, this is the difference. So for some n, can you finish the algorithm within n square? So we can't finish the algorithm within n square for some n. Okay, So for every sufficient large n, there is an input size of n for which magic path requires time proportional to n square. Okay. Okay. Like n must be always sufficient large, and you can't compute within n square because n square is less than n square log n. So this statement also true. So in last option, it is saying that for every sufficient large n, there is an input of size n for which magic path requires time proportional to n cube. So n cube greater than n square log n. Okay. So basically, if you see that what BGO basically says. BGO basically says that if this is the function, then this is the C of Gn. So this is basically the GO. Okay. So you have to find the upper bound, not the lower bound. So this was basically n square log n, and this was basically n cube. Okay. So you can write it as n cube, but not n square log n. So that's why D option is correct. Okay. So order of n square log n is an upper bound on worst case time complexity. It does not force any input to actually take that much time to solve. Okay. So it is the upper bound. It is the worst case. So the only contradiction is the statement that there are infinitely many n for which there are input of size n that take time order of time. Okay. Now this is the next question. Next question is, you are executing an algorithm with worst case time complexity order of n to the power 4 on a CPU that can perform 10 to the power 8 operation per second. Okay. Which of the following is the most accurate guarantee for the time required to solve a worst case input of size 800? Your CPU can perform 10 to the power 8 operation per second. So how much time do you take to calculate this one basically? If your input size is n, so your n is basically 800. Okay. So you need time n to the power 4 because this is big O of n to the power 4. So your n is 800. You need 800 to the power 4. So now they are saying that your CPU can perform 10 to the power 8 operation per second. So what if you do 800 to the power 4? Okay. So you can factorize this one. Okay. So you can factorize, and so basically what you can do, like 800 to the power 4 by 10 to the power 8. So if you do this, you can get that 4096 into 10 to the power 8. Okay. So this is basically 800 to the power 4 is the total time we require. Okay. So if we factorize this 800 to the power 4 into this one, like you just divide it. Okay, then you can get it easily. Okay, so you can get 4096 into 10 to the power 8, or so what will get? So for 10 to the power 8 operation per second. So how many minute do we need? We need 4096 seconds basically. because for 10 to the power 8 operation we take 1 second, so we need total 4096 second. So 4096 second is equal to 68.3 minute. Okay, so what is the best answer in this case? So we total need 68.3 minute. So 68.3 minute basically like near to 1 hour. So we can compute this operation within under 5 hours. Okay, so B is the correct answer. Yeah. Now suppose fn is n square log n. Consider the following statement: fn is equal to n root n, and fn is order of n square root n. So fn is fn is n cube. So which of the following is true? Okay. So this one is saying that n square log n is equal to this one is saying n square log n is equal to n root n, but no, this is not true, so this is incorrect. So A is not true. Okay, but n square log n is n square root n and n square log n. Okay, fn is big O of n square root n. Okay, so as we also encountered one problem that log n is less than root n. Okay, so this is this one. Okay, so this is true because this upper bounds this n square log n. Okay, so that's why. Then fn is order of n cube, so this is also true. So A is false, but B and C is true. So this one is the correct answer. So now this is our last question. So here what we have to do, that in this code fragment, that first and last are two integer values. Okay, first and last are two integer values, and composite x is a function. Okay, so this is a function basically called composite x, that this composite x is a function. So this function returns true if x is not a prime number and false otherwise. Okay, so from where we'll start. So this last and first are two integer values, any integer values. Okay, maybe this is 100 and this is 1. Okay, maybe you can, maybe this is 1. Okay, and each and every time it will be 100, 99, 98 to 1. So this is how this will execute. Okay, then what it will do, it will do k is equal to k plus m. K will start from 0. Okay, then this is the value of m. Okay, and this is the value of k. K is equal to, first k was, so k is equal to 0. 0 means 0 plus m, that is value of m, that's 100. So now check if composite m. Okay, so check 100, check this function composite 100. Okay, so composite 100 is a function that returns true if x is not a prime number and false otherwise. So if 100 is 100 is a prime number or not. So 100 is not a prime number, so it will return true. Okay, and it will go to this condition, I is equal to I plus m. If it was maybe composite 2, for composite 2 it will go to false condition because it is a prime number. So then it will be it does j is equal to j minus m, but here it does I is equal to I plus m. Okay, now this has been done. Okay, this for loop is done. Okay, now if what should be in case of in between if condition, so that we should find a true, we should print a true statement. So which of the following expression can we put in place of missing condition to ensure that program prints true? Okay, what should we put here? So in terms of if, what should we put from k is equal to I plus j, or k is equal to I minus j, or k is equal to j minus I? So which value should we put there, so that we can get a true, we can get true as printed statement. Okay. So you can see that like for each and every iteration, so what is being checked, like you can see here, so I have to check in terms of k. Okay, so how this k value is changing? So in every iteration, the increase in k is matched by an increase in I or decrease in j. So you can see that if it is a composite number, if it is not a prime number, then you will get increase in I. If it is not a if it is a prime number, then you will get decrease in j. Okay, fine. So k is matched again an increase in I or increase in j. So what will be the two, increase in I or increase in j? Okay, so this is what I want to convey, that k is matched against increase in I or decrease in j. So which one is increasing or which one is decreasing? So I value will be greater or j value will be greater. So you can see that like prime numbers are less. Like if you check between 1 to 100, so prime number are very less. Okay, so I is, so if whenever the number is not a prime number, so I value will increase, so I value will be a greater one. So what I will be doing I minus j. Okay, why? So so that's why k is equal to I minus j is an invariant. So if m is composite, then okay, so if m is a composite number, then how it change? K is equal to k plus m is equal to I plus m minus j. And if it is a prime number, if it is not composite, then how it is changed? Is changed to I minus j minus m. So let me write it clearly. So k plus m is equal to I plus m minus j. Okay, and when composite, okay, when prime, how it will change? It will change like k plus m is equal to I minus j minus m. Okay, so what I should put here? K is equal to I minus j. Okay, so yeah, so I think like this is clear to you, because how we are getting I minus j, because like each and every time how k is changing. K plus m is equal to I plus m minus j. So m and m will be cancelled out, so you here also you will be getting I minus j. And also whenever this is prime, then k plus m is equal to I minus j minus m. So j plus m, so this minus will be common, so it will be k is equal to I minus m. So for composite case also, for prime case also, so you will be getting answer as k is equal to I minus j. Okay, so thank you everyone. So this was the question I prepared for today's lecture. Okay, I think this is enough for your like quizzes and all. So please practice regularly to solve the question. So if you
Thank you,
yes,
sir. It was a very informative session.
thank you.
Sir, I had a question.
Yeah.
Sir, are you going to upload this video on YouTube or give us the PDF somewhere in some platform like Classroom or anywhere?
Yes, from the coordinators, we told that I will upload the video in YouTube. Maybe you will be getting the link as an email, or if not, I will give you the link in the next class. Okay. Uh, so fine.
Thank you, sir. Thank you, sir. It was a very informative lecture, sir.
Yeah, thank you so much. So in the meantime, if you have any question, so you can post in the forum, so I'll give you the reply. Okay.
Thank you.
Yeah, thank you so much. We will meet on next
Thank
week.
you, sir. Good night.
Good night.
Sir, every week we are going to have the class on the